All right, guys, so 7.6 says double angle and half angle formulas. So we are going to start with double angle for sine. Okay, so your first identity for double angle is sine. I'm going to write sine of 2 theta. Doubling meaning that is 2 of it. So sine of double angle is going to be 2 times sine of theta times cosine of theta. We are going to highlight this because, guys, you will need to memorize this. But before you are going to memorize it, I'm going to prove it to you of how or where this came about, okay? So, prove it. Now, how did sine of 2 theta become 2 sine of 1 theta times cosine of 1 theta? As you guys already know, you guys have your sine of alpha or sine of A plus B. The identity for that is sine of A times sine of B, sine of A cosine of B, my bad. Sine of A times cosine of B plus cosine of A times sine of B, okay? Now, what if I said, guys, let angle A be exactly the same as angle B. Let A be the same as B. So if that's the case, then we would have sine of angle A plus, we're going to take out B and put another A because they're exactly the same, right? So angle A plus A equals, so every time, guys, I see an angle B, I'm going to substitute that with A because since they are the same, it doesn't really matter if I use A in its place or not. So as you can tell here, A plus A is sine of 2A. Now that's what the doubling is coming in, right? Now sine of A times cosine of A, and then there's another one over here, sine of A times cosine of A. Now multiplication order doesn't matter. So that means in essence, these two are exactly the same. So if they are the same, we can combine them to make 2 sine of angle A times cosine of angle A. So guys, this is the same as if we were to use theta in its place. Exactly the same. Okay, so that's the first one. The next one is going to be for cosine of a double. Cosine of a double, guys, will come from, we have a couple of these, so I want you guys to make sure you guys are paying attention, okay? Cosine 2 theta is, the first one we are going to do is cosine square of theta minus sine square of theta, okay? Then another one for cosine is, we're going to write them first and then we will prove it, okay? Cosine of 2 theta is cosine 2 cosine square of theta. So 2 cosine square of theta minus 1. And then the third double angle of cosine is going to say 1 minus 2 times sine square of theta. All right, guys, I want you guys to highlight this and I want you guys to memorize on these, okay? And yes, you have to memorize it because you're not given anything here. Okay, kids, let's go and prove it, okay? So let me, okay, prove it. Very similar to sine, we will start with cosine. I'm going to say alpha plus beta, okay? So the identity for cosine of alpha plus beta is cosine of alpha times cosine of beta minus sine of alpha, or A. Since I'm using alpha, let's keep it as alpha, times sine of beta. Sine of alpha times sine of beta, okay? And just like what we just got done doing with the sine, we're going to say, okay, well, let angle alpha be the same as angle beta. Okay. So what that means is, guys, I can take out, okay, I can take out all of the betas and let it be alpha since they are exactly the same. So on this side, alpha will stay, beta, remove it and put alpha in its place. And same thing with sine, take out beta and put alpha in its place. Well, an alpha plus an alpha is now 2 alpha or 2a. Feel free to write 2a. All right, this one is going to say cosine of alpha times another cosine of alpha. So that's cosine square. And sine of alpha times sine of alpha is sine square of alpha. So this is your first one, okay? Cosine of 2 alpha is the same as cosine square of an alpha, take away sine square of an alpha. So as you can see here, this first one is that, okay? Now the next one we want to see where it came from is we are going to require Pythagorean theorem. Pythagorean theorem said sine square, right, of alpha plus cosine square of alpha equals 1. So with manipulation, guys, we can say, okay, cosine square equals 1 minus sine square of alpha. Similarly, we can also move cosine square to the right side. So if we move cosine square to the right side, sine square equals 1 minus cosine square of alpha. Well, where is it going to come from? Well, we're going to take this right here and we're going to say, all right, let's cosine of, sorry, my computer's frozen. All right, 2 alpha, cosine of 2 alpha. Let's say I want to get rid of cosine square. Well, cosine square is then 1 minus sine square. So it's going to say 1 minus sine square of alpha minus the sine square alpha on the back end. So this is where your other identity for the double angle of cosine comes in because of Pythagorean theorem. Okay, so now cosine of 2 alpha, oh, that looks like alpha and alpha. So let me just write the 2 a little bit better. I'm trying to erase, but it's not letting me erase because my computer is extremely slow here. So, okay, there you go. All right, let's do that again. 2 alpha equals, well, a negative sine square and another negative sine square is minus 1 minus 2 times sine square of alpha, okay? This identity right here, guys, let me highlight that and kind of connect it for you. This is the same as the third one, as you can see. Okay, this one and this one, they are exactly the same. Now, then we can also show you guys how do we get the last one. So cosine of 2 alpha is, this time I want to take away the sine square. So cosine square of alpha minus, well, sine square is the same as 1 minus cosine square. So 1 minus cosine square, right? So this is going to become cosine square of alpha minus 1 plus cosine square of alpha. As you can tell where this is coming from, right? Because cosine square plus another cosine square, that's going to be 2 cosine square. And then, so that is 2 cosine square of alpha minus 1. So as you can see, let me pinch it in, if my computer allows me to pinch it in. Okay, so this one, guys, is connecting with this one, okay? All right, so those are your 3 cosines. Now we're going to go to, let's do tangent. Okay, because the reciprocal functions, we don't need to prove those because all we need to do is take the reciprocal of these original ones, okay? Now tangent, let's write tangent and then we'll prove it for you guys, okay? Tangent of 2 theta is 2 times tangent of theta divided by 1 minus tangent square of theta. And then I'm going to highlight that, and then I'll prove it to you guys. Okay. All right. Prove it. So let's start with tangent of alpha plus beta identity. So based on that, guys, it's tangent of alpha plus tangent of beta all over 1 minus tangent of alpha times tangent of beta. And very similar process, we are going to let alpha be beta. Okay, the same thing, alpha be beta. So because alpha and beta are the same, as you guys saw already, right, we can take alpha out or beta out and use the other. So then tangent of alpha plus alpha equals tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha times tangent of, oops, remember we want to take all the betas out and substitute that with alpha. So let's get rid of that beta, okay? And then put alpha in its place. All right, let me move up really quickly. Okay, so as you can see here, tangent of alpha plus alpha, that's 2 alpha. Remember, variable doesn't really matter. You can use alpha, you can use theta, you can use A, you can use B. Now, tangent of 1 alpha plus tangent of another alpha is 2 of that. And then divided by tangent of alpha times tangent alpha is tangent square of alpha. So that's where that comes from. Okay, so on this page, we have these lines right here. So let's write the identity all the way down here so we can have it all together in one place. So let's write tangent first because that only has one line here. So tangent of 2 theta, students, is 2 times tangent of 1 theta here divided by 1 minus tangent square of theta. Then we are going to do, let's do sine next, okay? Sine of double angle is 2 times sine of theta times cosine of theta. Okay, let's do cosine next. Oh, look at that, guys. I have an extra line for no reason there. Okay, next one, let's do cosine. Cosine, the main one is this one. Cosine of 2 theta is going to be cosine square of theta minus sine square of theta. Then we have the other two, cosine of 2 theta by using Pythagorean theorem, 1 minus 2 times sine square of 1 theta. Then the last one for the cosine, so that way we can have it all in one spot. 2 times cosine square of theta minus 1.